Okay, so this light right here was on last night when I was out to look at the lunar eclipse, which I didn't see because of the clouds. But it let me know, since this loader's been sitting here for about a week, that we had a wiring issue to look at. Along with, we got pretty LEDs on here now. But yeah, that light should not have been on because the ground switch, which disconnects the ground to the battery, it was turned off, but the light was still on. Guess we'll go to the whiteboard and talk about it. Last night, there's supposed to be an eclipse out here in Fairbanks, and I went out to look at it. Clouds all over, and I saw one of the lights on the loader that's been sitting outside for a week. And I said, oh, that's not the way it's supposed to be, because we had ground switch. So you have a switch for your ground, and then it goes on over to the negative on your battery. And in this case, we have a second battery. So this is 12 volts. This is 12. Simple, John. 12 volts. So you have a 24 volt system, and then this one here goes on to your different things. The idea being, if your ground switch is off, nothing should come on. But let's go back to earlier systems, because I just kind of wanted to talk about a few different things I've ran into on similar systems with this. And part of what this is we were drawing things off here for 12 volts. And those people that have ran into this before know exactly what happened, but the rest of you will fill you in. So let's start out. Initially, our automobiles that we were running 6 volts. And with our 6 volts, and we'd have it grounded, of course. And then you'd go out and you'd run all of your stuff on your vehicle. You'd run your gauge, run your starter. I guess I don't really need to make drawings for every little thing that I'm doing. But like when I first got involved with using the multi-systems like this was in my 48 Jeep. And I had a 48 Jeep, and it had on the gauges, of course, were 6 volt. I could buy 12 volt lights. The starter didn't really care. I wanted to convert it to 12 volt like a lot of people do. But you have problems for some of your minor stuff like running your gauges. Now, on that one, it had the back of the gauge panel. It had a speedometer, and I think there were 4 clusters. I think this one was nothing in it, but it 4 openings and speedometer in the middle. But on the back of the fuel gauge, it had a little voltage regulator. And some people call it a voltage limiter. And also a lot of people are going to say, well, that should have been on there only if it was converted to 12 volt. Well, some applications, they put those on 6 volt vehicles too. And if you look up the information for them, they will talk about that being regulated to 5 volts for a more consistent voltage for the gauge panel. In 1958, 57, when most all the vehicles went to 12 volt, they put a different regulator in here. Now I've seen a few things, because I just recently looked at this, like the Ford pickup from 48 to 50, not to 52, it was way into the 60s. Anyway, but starting in 58, they claimed it used the same regulator, all the way from 6 volt up to 12 volt. How that works, I don't know. There's also some people that say that that regulator is a current regulator as opposed to voltage, in which case it wouldn't really matter what you hooked it to. I don't know. But that's just one of the side things that you run into when you're talking about 6 and 12 volts. What I knew for sure about the gauge was the gauge panel was meant to run with 6 volts into it, and I didn't want to run it with 12 volts. So what I did was I mounted a second battery in the vehicle, and I also built brackets and new pulley so that I could run a 12 volt alternator. And then we just plain had our alternator, put power out into the battery, and then we had our 6 volts in between the two would come over here, and it worked fine. Now, if you draw too much power off of the 6 volt portion of it, which the gauges are almost nothing. But if you draw a lot of power off of here, you're going to have a little bit of imbalance in your charging. And this one battery that's not having the extra draw will always be towards a little bit higher voltage. It's not that detrimental if it's a small amount, but if it's a major amount of difference between the two, it can make a difference. Another thing that was done back in those days is you would, separate from all of this, is you would use, and the regulator still worked, it didn't care, but you would put in, instead of a 6-volt battery, you'd put an 8-volt battery in your car. And they'd put in an 8-volt battery, you'd readjust your voltage regulator, and you do that so that your 8 volts cranks your starter quicker. The 6-volt starters were slower. And they crank really good on 12 volts, but they're not exactly the same as a 12-volt starter, but for the most part they work. And the reason for that is because they turn faster, they get more cooling. So they would go to 8 volts, and then they made them that fit right in place of the 6-volt battery. You change your voltage regulator, your lights were a little bit bright, and it was okay. So that was one of the things that they do. Today, another thing that they'll do when they're running the 12 volts is they'll just go here. Instead of having an 8-volt battery, they put a 12-volt, and they'll put a different type of a regulator in over to your gauge panel. Now, most of the regulators today are electronic. In fact, if you go to buy a replacement for one of these, it's going to be electronic, where the original was a bimetal strip that clicked back and forth, turned on and off, and would have made very bad voltage for your radio. It would have been very noisy. But one of the things with the electronic ones is they definitely have an amperage maximum. And most of them are relatively low in amperage, and that's part of where I prefer the dual battery a lot of times. Another thing that is done with these 12-volt and, well, let me see, another thing here first on regulators I wanted to talk about too. If you go back into the early days of the 12-volt to 6-volt, there were a couple of different things they had. One was adjustable, which was, it would be a board and the same exact component. It would have a whole bunch of coils of resistance wire on it, and you'd have some little places where you could put jumpers that would slide and go across, so you could change the resistance on it. So what you would do is you would put your 12 volts into it, and then you would have this going to your radio. And so what you'd do is when you'd hook it up to your old 6-volt radio, you would adjust these so that it came out with the right voltage. Because if it wasn't a regulator really, it would just be for that general thing. Another thing you used to see in the old catalogs is you'd see where they'd sell you specific resistors for how much you were going to draw. So they'd just calculate, you're going to draw 2 amps, you're going to draw 3 amps, whatever you're going to draw, then that's what you do to get your 6 volts that you want there. Because it was generally according to the amperage, how much power you were going to use. Which if you didn't know, or if you changed things later on, it caused people a lot of problems. It was not a really good or accurate way to do things. Another thing that is really, and I'm going to go back up, I'm going to go up to the 24 volt like we have on our loader for this, because while they did it on automobiles, it was very, very common on semi-trucks. And what they would have is they would have a series parallel switch. So there would be a relay that would connect to the second battery, and this would go to your starter motor. And of course your starter motor over here is grounded. And the relay would have a coil that operated it, and at the same time that it operates that contact, I'm not going to bother drawing all of it. It releases other sets of contacts. So it connects these 2 batteries in series in one direction, and then on the other direction, it would connect them in parallel. So they would be in series, and then once your starter started, it would disconnect both of these, and then it would come over here and connect this one and connect that one, and then you would have your charging from your generator. It's longer than the alternator, so that's why it's a generator. And your generator would charge back up. And also one of the things when you see those, these are smaller wires. And then there's one extra wire which is important in here. When this pulls down into the series parallel, there would be another contact set also, and this would go over to the solenoid so that your solenoid could kick on for your starter. And they did that separate switch because they wanted to make sure that the series parallel was engaged before the coil kicked on. You didn't want to kick the coil on and then try and make a series parallel switch or have it drawing high amperage through these 10 gauge wires instead of the battery cables. Because that's all these were. These were 10 or 8 gauge. I've never seen any that were smaller than 10 gauge. But anyway, and so you'd have a 12 and 24 volt on your truck. Part of that was on equipment where it was running already on straight 24 volt charge, 24 volt battery, 24 volt lights. You have problems from legal because we're worried about fires. Nowadays with electric cars, we have 500 volts out here on the road, and I don't know what the laws are, but at this time, it was illegal to run over 12 volt nominal on an automobile vehicle. Now people say, oh, I had an old Jeep, I had an old military. The military was exempt. They had some of them that even had 36, but the normal was 24 volts. And if you buy one of those, since it was legal, if it came with a title, then you can license it and it's legal on the road, but they can't build them with the 24 volt back years ago. What a lot of them have done today for the trucks is they've just gone to straight 12 volt. They've just gone bigger wires, starters that work better on 12 volts, and they've just gone straight 12 volts for a lot of the trucks today. I don't know of any with a series parallel switch, but they could be. I haven't been playing with trucks much for quite a while. So we got that for our power. And starting. Now we got another thing going on here. Let's go back to the main thing I was working with the machinery, with the particular loader. And yeah, we'll go ahead and put our ground switch in here again. So we have our ground switch, we got a battery, we got another battery. We're connected between them. We got this one. And it goes over here to, just in general, that's 24 volt stuff. Okay. And then we hooked in over here to 12 volt stuff. So part of it, got to have an entertainment system. We're updating the loader. It has to have a radio. Not only a radio, but 6 speakers, bass boosted, I mean, it should be fun to drive. I'll probably never use it much. Well, I'll use it some, but anyway. I told Austin do whatever he wanted, so it has radio. So anyway, so that had to be 12 volts. We had no choice there. We did have choice on some of the other stuff. Is you can do, say you put in a light. Well, if you put in 2 lights and you hook them together in series, then they can run off of the 24 volts by being a 12 volt light and a 12 volt light. So you have the 2 in series, if they're the same wattage. Now, if they're different wattage, one will be bright, one will be dim. LED, we got a whole different story because LEDs have regulating inside of them. So the LEDs, and we bought LED lights for the loader. But we still hooked some of them up to the 12 volts because of the way that the new wiring was in, and the old wiring didn't really look good to Austin. So we wanted to run a lot more of it off of 12 volts, and the LEDs don't draw that much power to be a problem. But the thing with the LEDs is you see some of them that are labeled, like the ones we had, 12 to 16 volts. And others that are 12 to 30 or 8 to 16. all kinds of different numbers. When I bought these ones, they were supposed to be, I think, 10 to 30, I think was what it was said. The box said 12 to 16. So we did the logical thing. We took it out of the box, hooked it up to 24 volts, and left it sitting there for 2 days. Still worked fine. We figured that the box was labeled wrong. So we were not worried about it for that point. But let's stop here for a second. Let's talk about our lights, as long as we're just kind of going through all of this stuff. We have a light, and our other light should be a little bit neater. I have done these in past years with less. I don't know why I get sloppier and sloppier the older I get, but anyway, I do. So we have a light here, and let's say that it is a 12 watt, 12 volt light. So here's 12 watts and 12 watts. So the reality is when this is lit up, that is going to be 1 amp going through it. It is going to be a 12 ohm. Yeah, 12 ohms of resistor. So it will be 12 ohms. And this one would be, which you also, there's an interesting thing with filament lights, is that there is almost no resistance when they first come on. So that's something always to keep in mind too. Till they heat up a little bit, they don't have their resistance. They're very, very low resistance when they first are lit. So you get one that's really dim, it will not have its rated resistance actually. So with 212 watts, let's say that we wanted to add another light in here. So we add another light in here, and we're going to put it right in there. And we're going to put our 24 volts onto this side, and we're going to ground this side. Now what we've actually got is we've got two 12 ohms in parallel. And the simple thing is 2 12 ohms in parallel is 6 ohms for resistance. And so now you have 6 ohms over here, and you have 12 ohms over here. And something I meant to say earlier, like this here, where you've got 12 volts and 12 volts, that's called a voltage dividing. And you can use a voltage dividing circuit. Doesn't have to be balanced, it can be unbalanced. And this would be an unbalanced one. But what we have at this point is on this one, and the other should be able to do it, but I'm going to grab a calculator just because. Our total ohmage there is 18. So we have 24 divided by 18. Or do I have 18 divided by 24? I forget. I don't do this enough, people. We're going to cut out the part where I'm figuring this out again, because this is just too stupid. Yeah. There, I didn't have to figure it out. I knew it. Okay. So, the way you normally have this is E over R equals I. And E stands for voltage. I usually just do voltage, ohms, and amps because that's what I deal with. We could go back and forth, but this is the international symbol for amperage. And this is actually the international symbol for amperage, but they usually use an R. And so all the different worlds I deal in, automotive people do more stuff like this, scientists do this more, and engineers. So anyway, so that's the basic thing. So what we've got here is we've got a total of 18 ohms. So if we take our 24 volts, divide it by 18, that means that our amperage going through there is 1 1/3 amps. So our 1 1/3 amps times 6 means that we have 8 watts going into this bulb. And if we take that times our 12, means we have 16 watts going in over here. We could also, since we know it's 16 and 8 again as the divider, and they add up to our 24 that we started with, you've got 16 volts across here, and you've got 8 volts across this one. in your voltage dividing. But what happens here, if you look at this bulb's going to be really bright. It gets 16 watts or 16 volts also on it. And this one with 2 bulbs is only going to get 8 watts total for both of them. So you got 2 4-watt bulbs that are just going to dimly light there. Now what I think is part of what was going on, because you want to run this here, and one of the ways you do it, because you don't have 24 volts on battery lights, bulbs, 24 volt bulbs. We have industrial truck shops and stuff, and pretty much every town does, but a lot of times you're in a part of town where all you've got is automotive stores. So people use standard 12 volt bulbs and they put them on their 24 volt item. And what I think happened in part, there was one light that used to always be on it, and it had an 1157 bulb, which has 2 elements in it, a small one and a bright one, which is not as long but bigger. Anyway, and I think what they did, these here connect into the base of the bulb, and I think they hooked one of these to ground and one of these to the 24 volt supply. And that's my guess of what they did, because it didn't show up as being hooked to the battery directly in the middle. We didn't have any extra middle connection that was on there. And so I think that kind of played, that was the light that happened to be on. I think that played into it some, but not necessarily the whole situation. Let's come back here and look at this. What I think is going on, we have, and let's just make it simple, we'll just have lights. Let's say we have right here a light, and it is a 12 volt light, and it is, oops, it's not turned on. Yeah, it's not turned on, but it's connected to the ground. And we have a 24 volt light that comes from here, and it's a light, and it's a 24 volt light, and it connects to the same ground. Now, why you put in the ground switch is so that everything can be turned off. And the thought is that if we have a ground switch here, it is essentially your 12 volts. This light won't come on if we're just looking at that. And if we just look at the 24 volt light, it won't come on either from getting the ground. It won't have 24 volts. But these two grounds connect together. They're both connected together. So if these are left on, unhooking the ground switch is not going to stop these from running. It'll just be that this one over here, which was the one I was seeing, was running really, really dim. And that's because it'll come through the grounds. You'll get 12 volts feeding essentially 36 volts worth of light, which again will not divide out quite even, but it doesn't matter in this case. And if you want to know the general formula, which is a little bit easier for figuring resistance on, say we have two resistors in parallel. This is one I quicker in my head actually than the one that's supposed to be quicker. Have a resistance here and a resistance here, and this one is 6 ohms and this one is 12 ohms. And I should put the little emblem on it. So if we put those two in parallel, what you have is you have 1/6 plus 1/12 added together. You add the reciprocals. So now what we have is 3/24, and then you reciprocate. So if you take 24 and divide it by 3, that will actually be what your ohms is.
Wouldn't that be 3/12?
No. Oh, you're right. Yeah. Okay, almost there. Okay. 3/12. Yes. So 12 thirds, and that would equal 4 ohms. You add the reciprocal of the resistances, and you can add 12 of them together. It doesn't matter. You keep adding all the reciprocals together for parallels, and then after you add those together, you reciprocate, and that's your actual answer. What you're doing is the inverse of a ohm of resistance is a Siemens for conductivity. It's another term that's used. And what you're doing is adding the amount of Siemens, which is the conductive amount. And that's Siemens was one of those guys like Tesla and all the rest of them back in the day. He came up with some formulas and things and new stuff, figured things out. So the other one, which is much simpler and one that most people understand really easily, is resistance in series. If we have, I had 6 ohms and 12 ohms before. So now you just add them. It's just 6 plus 12 equals, quick, I'm gonna let you do it. I'm not gonna trust my math.
18?
18. Good man. If I couldn't come up with 12 right in that last one, I'm like, yeah, let's use the tools. Bert can help me out. He's been to school too. He's even been to college more times than I have, I think. At least for hours. Anyway. Yes, so little bits of math. One of the things to remember when you're looking at putting stuff together in series, though, is that unbalanced factor. You can run all kinds of things if they're the same size. You can run the things that you're powering just directly in series, and they'll divide out the power just fine. Now, you always have to remember what you're doing in the fine details, too. If you have something that has a low and high setting, like 2 radios, they can be a little bit of a problem because the one that's turned down low is not going to want to turn down low all the way, and it might even burn out because it's not using enough power, where the other one is turned up high and it's not going to play very well. So you would actually have to, if you were doing 2 radios, you'd actually want to keep the volumes matched on them as you're using them. So that would be a bad choice of things to put in series. In parallel, it doesn't matter. You've got a voltage across them, and they each get the voltage, the power that they need at that voltage. They each pull their own amperage. So anyway, and how will we fix this so that we don't have this problem in the future as far as it being out there and being dead? Is we're going to put in a second ground switch. And before I even figured out and thought about what's going on, why is this happening, I'd already figured we just put in a second ground switch, because if we disconnect both sides of both batteries, we can leave the center connected, it doesn't matter, and everything will turn off. Just another $100 switch, it's fine. Don't buy the cheap ones, they burn out all the time. For little stuff, for loaders and things. They're okay for cars. But I bought too many of them that were rated for 600 amps, and they used to be good. I used to use them on my semi-truck. They don't work anymore. The 600 amp ones, I'd say, are good for about 300 these days. They just don't work as good. So I buy the 1200 amp ones, and they pretty much work. Anything else of value? Any questions, Mr. Burt, while you're there watching?
That made a lot of sense. Yeah, that made more sense than back when I was in high school.
What about when you took electronics in college?
I didn't.
You didn't?
No.
Oh. I know. You took more important biological stuff.
Yeah,
really.
and they really glossed over, the voltages and all of that when you're looking at neurology.
Well, in chemistry, you got your voltage potentials for your different stuff, though.
Yeah, but they don't really talk about it too much.
Huh. Okay.
I guess they don't trust the college students with that anymore.
Yeah. Huh. Anyway, probably nothing else I can really think of right off to say, but I just wanted to mention a little bit, because thinking about that caused me to think of a few different things I've ran into with series. And doing the series parallel, whether it's a 24 volt, you want to put 2 lights together, which is not as much of a problem with the multi-voltage LEDs. But knowing about the stuff and knowing about the series parallel switches, And that regulator on the gauge panel, that will fool some of you when you see it on your 1938 DeSoto. I actually don't know if a DeSoto had it or not. It was a 48 Willys that did have it. I just saw when I was looking that International had it on some of their stuff. Ford had it. And it's obvious. You'll find stuff all over the place on the internet, which I used to read the books on this stuff when I was a kid, on wiring and mechanics out of the motors manuals. And there's a lot more in there. You just won't find the stuff on the internet. Nobody's putting it out there. They all go, oh, the voltage regulator for the gauges so that you can convert your 65 through 73 Mustang that had one that burned out, or you can convert your whatever. But it's not that simple. It was actually a gauge component before. And I think part of why they had it on some vehicles and not on others is either a matter of how much they cared. And when I saw them really coming through as much as I could see, it seemed like the Depression era, it was important. And they always put the regulator on the fuel gauge. Now, it may have been because that was a good mounting point. They kept them all consistent, but it also might have been that fuel level was really important during the Depression days. So that could have been why, and they wanted more accuracy. It could have something to do with a lot of the vehicles didn't have real accurate voltage regulations, just as we were going through and looking at all the different regulations and things on that 37 Ford that we were working with last year. And it originally would have had a 3-volt, 3-wire alternator, 3-wire generator, which a generator and an alternator are actually the same, but not quite. But we don't need to worry about words today. We talked about lights and voltage, and that was enough. Hopefully it was fun for somebody, and